In this lesson, we're going to learn about absolute value and how to solve equations and inequalities that involve absolute value. So notice that if we take the absolute value of 3, our answer is simply 3. But if we also take the absolute value of -3, our answer is also 3. And notice that 0 has no sign, so the absolute value of 0 is 0. Now, if you ask most students what the absolute value means, they typically say that it just means whatever's inside, make it positive. So what do the absolute value bars actually tell us? Well, I'll tell you what they don't tell us. They don't tell us just make what's inside positive. It's a common fallacy for absolute value, but it seems to work nicely when you're just taking the absolute value of numbers. What they really describe is the distance that inside quantity is from 0. So the fact that 3 is inside of the absolute value bars says that it is 3 units away from the value of 0 on a number line. Let's take a look at that if we were to now look at the absolute value of x equals 3. Notice that x is a variable, and our job here is to solve for the value of the variable that's going to make this statement true. And so we need to think of a number line and recognize that we're saying what values of x do we plug in that will be 3 units away from 0. Well, on our number line, you can notice that the value of 3 is 3 units to the right of 0. But we should also recognize that -3 is also 3 units away from 0. That's why we actually are going to get 2 different answers, and that's another reason why the absolute value of 3 and -3 both give me the same result. So for the solutions of the absolute value of x equals 3, my answers are -3 and 3, because they're both 3 units away from 0. Now, how do we solve absolute value equations in general? So if we expect that k is a constant, a positive constant, and you have the absolute value of some expression is equal to that constant, like the absolute value of x equals 3, then all we really need to make sure of is that the quantity on the inside is either positive k or negative k. So to eliminate the absolute value, you simply create 2 separate equations, one where you set the equation equal to k, and one where you set it equal to -k. So let's take a look at an equation like this. Notice that we can't really solve this yet until we get the absolute value expression alone on one side. So why don't we subtract 7 first to get that the right side is 42. And now if I divide by 2, I get an answer of 21. So now we see that the absolute value of some expression has to equal 21. So we should recognize that in order to make this statement true, that entire quantity on the inside, that entire expression, is going to have to be either 21 or -21. If you just cover up 6x minus 3, just think about how the absolute value of 21 will give me an answer of 21. But the absolute value of -21 will also give me an answer of 21. So all we need to do in order to solve is separate this into 2 separate equations, because we're saying that the distance between 0 and the expression 6x minus 3 has to be 21. So we simply set that quantity to 21 and to -21. And now we've got 2 separate equations to solve. But notice in order to isolate x, we're still moving everything in the same way. We're adding 3 to both sides, and now we divide 6 by both sides. Notice that this does give me, in fact, 2 separate answers, but we can see why that's going to give 2 answers as well if I were to plug this in to the original equation for x. I should get 49 on the right side no matter which number I plug in. Well, notice 24 minus 3 is going to give me 21. And -18 minus 3 is also -21. But now we're being asked to calculate the absolute value of a couple of numbers, and remember, no matter if that number is positive or negative, the result is still 42, or the result is still positive. So 2 times 21 is 42, and 2 times the absolute value of -21 is also 42. And notice that both of those give 49. Notice what we did not do. Looking back up here, if we just said whatever's inside, make it positive, that would imply that we somehow have to change that minus sign to a plus. But in order to solve, that's not at all what we did. We kept that sign, we kept the entire expression intact, and we just said when is that expression equal to positive or negative 21. Now there's certain instances where you have an absolute value on both sides. But just think about again what an absolute value means. If I were to have the absolute value of A equals the absolute value of B, which is what we see here, then that means that there's two numbers that have the same distance from zero. Well, let's just think about that for a minute. The only time that can happen is if the two values inside the absolute value bars are either the same number or they're exact opposites of each other. For instance, the only way for the absolute value of 5 to equal the absolute value of 5 is if both the numbers are 5 or one is 5 and one is negative 5. So notice in this case, we simply say when is 2x minus 3 equal to 4x plus 9? When are the two insides the same? Or when is one of them the exact opposite of the other one? Which is why on the right side, we simply multiply the entire expression by a negative. And now we solve. We subtract 4x on the left to get negative 2x. We add 3 onto the right in order to get 12. And when we divide by negative 2, we end up getting negative 6. So negative 6 is one of the numbers that's going to make that statement true. But it's not the only one. Because if I now distribute this negative to both terms on the right, I get negative 4x minus 9. Adding 4x is going to give me 6x on the left. And adding 3 is going to give me negative 6. So now we've got a basic one-step equation, divide by 6, and we find out that our answer is x equals negative 1. Just note for most absolute value equations, the answers are not going to be opposites of each other. So now I see that the answers are negative 6 or negative 1, so let's plug them in and see why. If I plug in negative 6 to both sides, I get negative 12 minus 3, and I get negative 24 plus 9. Over on the right side, if I plug in negative 2, I get negative 2 minus 3 in the bars, and I also get negative 4 plus 9 inside the bars. Now they don't look the same until I simplify the left and right sides, and now notice I have a situation where the numbers on the inside are the same, therefore they have the same absolute value, or the numbers on the inside are opposites, which means that they also still have the same absolute value. So anytime you want to solve an absolute value equation, in general, you normally want to set the equation equal to whatever the absolute value expression is, and then create two separate equations.